Today we're going to do the Johnny problem. So you have to hear a little story first. There was a guy named Johnny Rose who was in 8th grade honors algebra quite a few years ago. And this problem was assigned and he did not enjoy it. And he didn't get it right on the test. And so lots of kids struggled with it. So I said that it was going to appear on every assessment until everyone got it right. And so pretty quickly everyone learned how to do the question. And Johnny thought it would be funny if he just got it wrong on every assessment to annoy his classmates, which is kind of entertaining. And it went on for kind of a long time until everyone sort of badgered him to just get it right so we could move on. So the problem has stuck around mainly because we get to see Johnny and tell him that we're still doing it and that we call it the Johnny problem. And um, it's a really fun question. It's hard, but it's fun. Anyway, here we go. The first thing we're going to do is find out when this fraction turns into a negative number. So I'm looking at the denominator and I'm saying what would make that turn into a negative. Well, I know that when x minus 2 is equal to 0, that x would be 2. And if I went anywhere on the number line below 2, let's try 1. 1 minus 2 is negative 1. The denominator will become a negative number. Well, if this is a negative number, a positive divided by a negative is a negative, which is clearly going to be less than 4. So we know that anytime this fraction turns into a negative number, that we're going to have a negative fraction. A negative number has to be less than 4. So every one of those numbers will make this inequality true. So step 1 is determine when the number turns negative. If this was a greater than sign, I wouldn't want it to be negative, so I would know that everything below 2 doesn't work. So when the fraction turns from negative to positive is what you want to be figuring out. When is it changing signs? So that's step 1. Step 2 is figuring out when this fraction is going to equal 4. So again, we can see when it turns from positive to negative, when it hits 4, and then we'll see what we can do with that. So how do I figure out when 3 over x minus 2 is equal to 4? Some people like to put this over 1 so that it looks like a proportion, which it is one. So you guys know that to solve a proportion, you can cross multiply. So just your regular 4 times x minus 2 is 3, and you solve this equation. And you get the answer of 11/4, which is 2 3/4. So now I have these two boundary points. I'm going to plot them on a number line. And so my two answers were 2 and 11/4, which is the same as 2 3/4. Why are these open circles, not closed circles? Because this inequality is less than, it doesn't have an equal sign as part of it. Now we said if we went below 2, like let's try 1, let's try 0, the fraction's negative, and we know that everything that's negative is going to be less than 4. And now I'm going to look at 2 3/4. I'm going to plug in things bigger than 2 3/4. What about 100? 3 divided by 100, take away 2. I'm just going to call it 100 because it's close to 100. And 3/100ths is less than 4. The bigger this number gets down here, the smaller the fraction will be, and it will clearly be smaller than 4. So I now know that every number above 2 3/4 will also be true. So there's just a really small range that doesn't make this work. Between 2 and 2 3/4 doesn't work, and I like to test that out. So I'm going to plug in 2.1 and make sure that the place I haven't shaded actually doesn't work. 2.1 take away 2 is 0.1. 3 divided by 0.1 is 30. 30 is not less than 4. Whoops, not less than 4. So I feel pretty good about my answer. This is a problem a video you may have to watch over and over again to sort of get the concept. of how you find your boundaries and then how you determine where to shade. You're shading by testing some numbers, something less than 2, something bigger than 3, and something in between 2 and 3 to see where to shade. I hope everyone gets it right on the first assessment. Good luck.